Welcome back to The Deep Dive, the show engineered to, cut through the noise and deliver actionable expert knowledge directly to you. Today, we are on a pretty critical mission. We're charting the new AI frontier. And, we're moving light years beyond just simple reactive systems. We're diving deep into the world of truly autonomous AI agents.
Right. Systems that can actually do things.
Exactly. Systems that have perception, complex reasoning, and, maybe most importantly, can take action without a human constantly looking over their shoulder.
Yeah.
If the last few years were all about making AI talk, this next phase, it's about making AI do.
That's a perfect way to put it.
And we're not just, talking about the philosophy here. We are going to break down the entire end-to-end blueprint for launching these modern AI systems.
That's absolutely right. And for you, the learner, this is really the essential roadmap. We've synthesized a whole set of sources that detail, the organizational shift, the actual measurable business value, and the specific technical architecture you need to deploy.
Okay, so where are we starting?
We'll start with the huge business case. Then we'll drill down into the tech evolution, from basic RAG to what's called agentic RAG.
Agentic RAG, okay.
And then finally, we're going to unlock the critical infrastructure piece, the foundation. That means reliable, RESTful APIs and modern cloud orchestration.
So we've got the full scope here. Why these agents are the next big competitive battleground, what actually powers their intelligence, and the blueprint for how you can build them.
That's the plan.
All right. Let's unpack this, starting with the big why. Why this shift to autonomous operations is happening right now. So the buzzword is AI agents, but we should probably define that clearly. How are these agents, fundamentally different from the old rule-based chatbots or the automation a lot of companies already have? What exactly is the agent advantage?
The agent advantage is really a shift from being reactive to being proactive. It's about goal-oriented autonomy.
Reactive to proactive.
Yeah.
Okay.
Yeah. Think about it. Traditional automation, it runs on predefined rules, on scripts. If the environment changes just a little bit, the whole thing breaks or a human has to step in.
Right. It's brittle.
It's very brittle. AI agents, though, they're designed with 4 key capabilities that the older systems just didn't have.
And those are?
First is context perception. Then there's the ability to maintain long-term memory, which is crucial. Third is tool integration, so it can interact with the outside world. And finally, a reasoning engine that can actually set goals and make multi-step plans.
So it's not just processing information anymore?
No, not at all. It's deciding what to do next to achieve a specific goal.
And what does that shift really mean in terms of, hard business value? We keep hearing about these massive cost savings.
The impact is structural. The number that gets cited most often is this dramatic cost reduction. By automating these highly repetitive, high-volume tasks, think about basic IT provisioning or first-line customer support triage, or even processing thousands of invoices. Enterprises are consistently reporting a 40 to 70% reduction in the costs for those operations.
40 to 70%, that's a number that makes a CFO sit up and pay attention.
It absolutely does.
But when you see that level of automation, is it just about replacing human work, or is it changing the type of work that people are doing?
It's definitely the latter, and that's reflected in what we call the proactive workflow advantage.
Okay.
Older systems were, by their nature, reactive. They'd wait for an error code or a customer to complain. But these autonomous agents, they're continuously monitoring the environment. They're watching server logs, inventory levels, transaction streams.
It's always on.
Always on. And if they spot an anomaly or an issue that's developing, they autonomously kick off a mitigation plan before it blows up into critical downtime.
So it's preventative.
Exactly. This ability to spot and solve problems proactively, it minimizes disruption, ensures business continuity. That's a benefit that's way bigger than just saving on labor costs.
So the role for the human team moves away from just fighting fires all day.
Right.
And it becomes more about setting the long-term strategy for this new automated workforce.
That's it, exactly. And that leads directly to human empowerment. You delegate the repetitive, high-volume stuff to the agents, and suddenly your human teams in IT, in sales, in finance, wherever, they're free to focus on the complex problems.
The stuff that requires actual creativity.
Yes. Creative development, strategic initiatives, things that require real human ingenuity. The agents handle the tactical execution, and the humans can drive the strategic vision, the whole organization becomes more productive.
And the sources we looked at, they back this up with some very specific, very measurable ROI metrics, don't they?
Oh, absolutely. The hard numbers are there.
Give us a couple of those that really show this shift in action.
Okay, so in IT service management, we're seeing deployments of autonomous agents report a 33% faster resolution time for critical IT incidents.
43%.
Yeah.
That's nearly cutting it in half.
It is. And that kind of rapid response affects the entire organization's productivity. Or look at retail and supply chain. Using agents for predictive demand forecasting has led to 60% fewer stockouts,
60%.
which translates directly into retained revenue and, of course, a much better customer experience. These aren't just soft, fuzzy metrics. They're bottom-line improvements tied directly to the agent's ability to act on its own.
So that brings us to the core structure. What's the fundamental architecture that lets an agent perceive, reason, and then act? Let's get into the weeds on these 4 components of the agentic core.
Right. So to be autonomous, an agent has to sort of mirror certain aspects of human intelligence, but obviously in a constrained digital environment.
Right.
So first you have the sensors. This is the perception layer. It's how the agent observes and collects data from its environment.
So this could be anything, like a user request or a log file.
Anything. It could be a webhook alert about a system failure. It could be reading a log file, processing that user request, or even querying a database for current inventory levels. The quality of the sensor input really dictates the agent's awareness.
Okay, that's perception. What's next?
Second is the reasoning engine. This is typically a large language model, an LLM at its core, but it's actually much more than just the LLM.
How so?
It analyzes the input from the sensors, it references its goal, it accesses its memory, and then it generates a multi-step plan to achieve that goal. It's the decision-making unit. It decides which tools to call and in what order.
So then the third part must be the action part.
Exactly, the actuators, the action layer. If the reasoning engine makes a plan to, say, fix a server, the actuators are the tools that actually execute that plan.
And in a modern system, that means APIs, right?
Almost universally. These are external API calls. It's a REST API endpoint to provision a user, a SQL query to update a record, or an HTTP call to notify a team on Slack. The ability to integrate and reliably call these external tools is what defines autonomy.
Okay, so sensors, reasoning, actuators. What's the fourth piece?
And finally, memory. This is so critical for maintaining context across multi-step or, multi-turn interactions.
And in a conversation.
Exactly. Agents need both short-term memory, the immediate conversation history, and long-term memory, which could be historical actions, learned behaviors, or facts it pulls from a knowledge base. Memory ensures the agent can execute these complex, sequential tasks without losing track of its original goal or what it's already done.
And this is where frameworks like LangChain and LangGraph come in. They're basically the plumbing to connect all this.
Precisely. They provide the standardized scaffolding, the logic flows to wire those 4 components together efficiently. They connect the LLM, the reasoning engine, to the external tools, the actuators, and they manage the whole input-output flow. It just massively reduces the boilerplate code you'd need to write.
So developers can just focus on the unique business logic.
They can focus entirely on the unique planning prompts and the specific tools their business needs.
Okay, let's move from the theory to some tangible deployments. When we look at something like IT and service management, this idea of a self-healing infrastructure, it sounds like science fiction, but it's becoming a reality.
It is, yeah.
What are the actual steps an AI agent takes to let an IT system handle an incident and literally fix itself?
So that self-healing mechanism, it relies on that full perception reasoning action loop we just talked about. And it's specifically designed to just eliminate the human delay in incident response. It really boils down to 4 key operational improvements.
Okay, what's the first one?
First is automated monitoring and triage. The agents are ingesting huge streams of data from observability tools. But here's the critical part. They don't just register an alert. They use their reasoning engine to classify the incident by severity and potential root cause based on historical patterns.
So it's not just something's wrong, it's this specific thing is wrong and it's a priority.
Exactly. And it immediately initiates the right response playbook. This instantaneous triage just massively reduces the mean time to resolution, the MTTR, because the fix starts in seconds, not minutes or hours.
That classification ability is so key. So how does the agent handle the kind of high-volume, repetitive fixes that just bog down human IT teams?
That's where the second and third steps come in. For common faults, the agent might proceed to an intelligent service restart, which often solves the issue instantly. But for more complex things, they manage sophisticated patch management.
Which is always a high-risk process.
It's extremely high risk. The agent manages the whole process of testing compatibility in sandbox environments. Then it sequences the deployment across non-critical systems first, and only deploys the updates everywhere after it's been validated.
So it automates the caution that a human engineer would apply.
Right. This structured, automated approach just dramatically reduces the chance of human error and, patch-related incidents.
And all of this together has a cumulative effect.
Oh, a staggering effect. It results in massive ticket reduction. By automating things like provisioning, identity management, and first-line diagnostics, these high-volume, low-complexity tasks enterprises are seeing a 40 to 60% drop in IT help desk tickets.
Which frees up the human experts for the really hard architectural problems.
Exactly.
And we can't forget the agent's role in just providing instant knowledge for the issues that do need a human.
Absolutely. The agent acts as this hyper-efficient knowledge layer. They can handle 70 to 80% of routine IT inquiries.
Like, how do I reset my password?
Exactly. How do I reset my VPN password? Or where's the documentation for the new API? They handle it instantly. They pull the correct, up-to-date answer from the knowledge base using ARG, and they bypass the help desk queue completely. So your human staff are only dealing with the truly novel, complex problems.
Let's pivot to the revenue side of things. Customer experience and sales. Here, speed and personalization are everything. How do agents accelerate revenue through a better CX?
The change in CX is all about context.
Yeah.
Agents provide this always-on support, but it doesn't start from zero every time.
Okay.
When a customer submits a ticket, the agent doesn't just read the subject line. It queries the CRM using the customer ID, and it pulls in the full history of prior purchases, support issues, communication preferences, everything.
So it knows who it's talking to.
It knows exactly who it's talking to. And this contextual triage leads to an 80% first contact resolution rate for common issues.
80%. That's incredible.
It's because the agent has all the information it needs right up front to either solve the problem or route the ticket to the exact right person. This cuts customer wait times by more than half, and it turns a potential pain point into a really positive interaction.
Okay, so that's support. Moving over to sales, how do they actually generate new revenue?
Through personalized offers and predictive analysis. The agents are constantly analyzing customer behavior, purchasing patterns. They don't just wait for an order, they anticipate what's needed.
You can give an example of that?
Sure. Let's say a customer buys product A pretty frequently. The agent knows that 70% of people who buy product A upgrade to service B within 6 months.
Okay.
So the agent can proactively trigger a highly personalized email or notification recommending that service at just the right time. This predictive capability is resulting in a quantifiable 25% uplift in cross-sell revenue.
And the sales process itself, the hunting part, is famously labor-intensive. How do agents help there?
The efficiency boost is just tremendous, mainly through smarter lead qualification.
Right.
A sales rep used to spend hours manually researching a prospect. Now, an agent can take a raw lead list and autonomously enrich the CRM data. It scrapes external sources, LinkedIn, press releases, industry news, to build out a really detailed profile.
But it's more than just data collection.
Oh, much more. The agent then uses its reasoning capabilities to score the prospect's intent. Is this lead actively looking for a solution? Did their company just get a new round of funding? This level of qualification means your sales reps are only contacting leads who are genuinely ready to buy.
And the results?
A 35 to 50% jump in conversion rates. And at the same time, it saves the sales teams 10 to 15 hours per week that they used to spend on manual research.
That is a powerful combination. Better targeting and huge time savings. All right, let's look at the corporate guardrails. Finance and compliance. This is an area where accuracy and following the rules are just paramount.
Right, and in finance, agents are basically tireless internal auditors and efficiency machines. Take expense autopilot, for example. Agents can use optical character recognition, or OCR, to process receipts, extract all the line items, categorize the expense, and they use complex internal business logic to route the approval workflow.
And that whole process used to take days.
Days of manual work. Now we're seeing a 70 to 80% reduction in processing time.
But speed is one thing. If the expenses aren't compliant, it's useless. How does the agent handle the policy side?
The agent is programmed with policy compliance as its primary directive. It checks every single expense against the company's spending rules, maximum limits, approved vendors, things like that, and it automatically flags any deviation.
And that's effective.
Incredibly effective. It leads to a proven 98% policy adherence rate. The source material shows that enterprises are saving, on average, $280,000 annually just by eliminating manual errors and enforcing policy. Then you have the fraud and risk sentinels. These agents are monitoring every financial transaction in real time, and they're not using static rules. They're using advanced machine learning models to spot these very nuanced patterns that might indicate fraud.
And that's more accurate than the old way.
45 to 60% more accurate. And just as important, it reduces the number of costly false positives, which makes the human risk teams much more efficient.
Okay, before we dive into the technical blueprint, let's just touch on two other key sectors. Give us the highlights for healthcare and retail.
Sure. In healthcare, agents are becoming vital clinical decision support tools. They ingest and analyze huge amounts of patient data, medical history, lab results, imaging to suggest potential diagnoses and treatment plans to doctors.
And this actually speeds things up.
It results in a 35% reduction in diagnostic time. Plus, by automating all the clinical documentation and admin tasks, they're cutting the physician's administrative workload by 40%. That's more time with patients.
And for retail?
For retail and supply chain, it is all about optimized logistics. Agent-driven demand forecasting models analyze everything from weather patterns and social media trends right alongside historical sales data.
To get a more accurate picture of what's coming.
A much more accurate picture. This kind of detailed prediction is reducing stockouts by 40 to 50% during peak seasons, and it ensures inventory is aligned with need, cutting excess inventory costs by 25%. It's all about the agent's ability to perceive and act on these complex, multivariable data sets.
Okay, let's unpack this core technical challenge then. An autonomous agent it's only as good as the information it acts on.
Exactly.
It needs specific, current, and verified context, stuff that's way beyond its static training data. And this brings us to RAG, or Retrieval Augmented Generation.
Or RAG is absolutely indispensable for taking LLMs from being, interesting generalists to being trustworthy domain-specific workers.
It's the thing that stops them from making stuff up.
It's the mechanism that combats the whole hallucination problem, yes. RAG works by making sure that before the LLM generates a response, the system first retrieves relevant authoritative documents or data related to the query.
So it grounds the model in facts?
Exactly. It provides that context-specific grounding, guaranteeing the final output is accurate and based on verified knowledge, not just, internal speculation.
It's like the system's ability to look up the answer in the corporate policy manual before it writes the email.
That's a perfect analogy.
Okay.
And this is a big but. When you move to these autonomous, multi-step agents, traditional static RAG starts to show its limitations pretty quickly.
Why is that? What are the limitations?
There are 4 major pain points that really stifle enterprise agents. First, you get generic and irrelevant snippets. A basic vector search might return parts of documents that are just too broad, and they lack the specific nuance the agent needs for its task.
Okay, so the results are noisy.
Very noisy. Second is the reliance on outdated or unvalidated information. If the data pipeline feeding your RAG system is slow, the agent might be acting on stale data. And that can lead to real-world errors, like deploying a security patch based on an old vulnerability report.
Ouch.
Yeah. Third, traditional RAG just provides surface-level context. It pulls documents. It can't prioritize one source over another or critique the quality of what it found.
And the fourth.
And this is the most critical one for autonomous systems. It lacks multi-hop reasoning. A complex query might require pulling data from a CRM database and a separate troubleshooting guide, and then combining those two pieces to form a plan. Traditional RAG just really struggles with those kinds of connections across different data silos.
And this is where it gets really interesting, because that failure in complex reasoning is exactly why we needed the evolution to agentic RAG.
Exactly.
So how do you literally embed autonomous intelligence into the retrieval process itself?
Agentic Oregon transforms that static lookup into an intelligent, goal-oriented workflow. So instead of the user's query going straight to a vector database, it first hits an agent, a dedicated reasoning engine, that directs the entire retrieval process.
And what does that enable?
This new architecture gives the system 3 core superpowers. The first is dynamic tool choice.
Okay.
If the agent gets a query like, What's the average transaction value for client X in Q3?
Mm.
The agent might first try an SQL query against the database tool. If that fails or gives errors, the agent autonomously decides to switch tools and maybe do a vector search on unstructured financial reports. The agent picks the best tool for the job.
So it can adapt its strategy. What's the second superpower?
The second is query reformulation. If the first search gives bad results, the agent doesn't just give up. It critically looks at the results, reformulates its search terms based on what it did find, and then it launches a second, more precise search.
It refines its own questions.
It does. It might even break a complex original query into several simpler sub-questions. And this all enables the third superpower: true multi-step reasoning. The agent can retrieve piece A, realize it's only half the answer, log that in its memory, trigger a new search for piece B, and then synthesize A and B to generate the final complete action plan. This iterative self-directed search is the essence of agentic RX.
So when you're deploying these systems in a company, our sources pointed to two main architectural strategies: the single agent approach and the multi-agent approach. What are the trade-offs there?
The single agent strategy is definitely the simpler path. It's centralized. All the functions, perception, reasoning, retrieval, action, they all live within a single model instance.
And that's good for it.
It's ideal for narrow, highly constrained domains, like automating one single, clearly defined HR provisioning workflow. It's just easier to deploy, maintain, and debug.
But the future seems to be heading in the other direction.
It absolutely is. The future is multi-agent, or what we call collaborative swarms. This is necessary for highly complex, large-scale enterprise automation. Here, you distribute the roles.
So you'd have different agents for different jobs.
Exactly. You might have a dedicated coordinator agent that gets the initial request, a retriever agent that specializes in getting data, a plan execution agent managing the actions, and even a critic agent that evaluates the final output.
And that distributed approach gives you what? Better scalability.
Much better scalability, better fault tolerance, and it lets you specialize and optimize each component.
The idea of a critic agent is fascinating. That brings us to these advanced ARGA variants. How do you actually ensure the output is trustworthy in a business-critical scenario? Tell us more about corrective RG.
Right. Trustworthiness requires explicit quality control. So corrective RG introduces a feedback loop that's based on confidence. Once the retrieval and generation steps are done, the critic agent evaluates the answer against a predefined quality threshold.
How does it do that? How does it measure quality?
It uses techniques like LLM self-reflection, basically asking the model to critique its own sources and its logic, or by retrieving secondary redundant sources to validate the core facts.
And if the confidence score is too low?
If it's too low, the critic agent triggers a re-retrieval and refinement process. The core mechanism is a loop: evaluate, then refine, then validate. This guarantees the agent doesn't act on low confidence information, which is, non-negotiable for finance or IT systems.
Or what about adaptive RAG? It sounds like that's dealing with the variety of data sources in a company.
It is. Adaptive RAG actually solve the right tool for the job problem. Enterprise data is scattered everywhere: structured databases, unstructured documents, real-time APIs. So based on an analysis of the query, the adaptive agent dynamically selects the retrieval strategy.
So it decides whether to use a keyword search or an API call?
Right. It uses metadata and query complexity scoring to decide instantly, should I do an exact keyword match, a fuzzy vector search, or should I make a live REST call to a stock ticker API? That dynamism ensures you get the best efficiency and accuracy, no matter the data format.
Let's try to ground this technical blueprint with a concrete example. If we're using a visual workflow tool, something like N8N, how do we actually build the core anatomy of one of these tool-using agents?
Okay, yeah, let's look at the practical side. In a visual environment like N8N, you'd start by selecting a specialized tools agent mode. This gives you the framework for tool use. Then you connect your LLM, Gemini, GPT, whatever, as your reasoning engine.
And then you add the tools.
And then you wire in your actuators, which are defined as tools. These are usually pre-configured nodes, like an HTTP request node, a database connector, or maybe even a custom script.
And the most critical part is telling the agent what to do.
That's the system prompt. It's the instruction set that governs the LLM's behavior. It has to clearly define the agent's personality, its main goal, and most importantly, explicitly instruct the LLM on when and how to call each tool you've attached.
So you'd write something like, if the user asks to schedule something, call the Google Calendar API tool.
Exactly, with these specific parameters. The quality of that system prompt really dictates the quality of the autonomy.
So what are the key configuration tips to follow to avoid, confusing the agent?
The LLM is smart. but it's very literal. So you need to follow 3 rules. First, use clear naming for your tools and parameters. The LLM needs descriptive names, not internal technical codes.
Okay.
Second, provide concise descriptions within the prompt for what each tool does and when to use it.
Three.
And third, and this is crucial, always test nodes standalone. Make sure your API call or function works perfectly before you connect it to the LLM. That way you can isolate bugs to either the reasoning layer or the execution layer.
And what about the memory component? How do you maintain context across multiple turns in a workflow like that?
The visual workflow simplifies this with a memory node and a context loop. You set up a dedicated memory node to store the conversation history. The key is you wire the output of that memory node directly back into the input of the next agent step.
So it creates a feedback loop.
Exactly. That loop means that every time the agent processes a new message, it automatically gets the full context of the previous interactions, including past questions and the results of any tools it already used. That built-in state management is just fundamental for building a reliable multi-step agent.
Okay, so an agent's ability to act, it hinges completely on its ability to interact with the outside world.
Right. It's all about the APIs.
Which means calling external APIs. And if those communication lines are slow or inconsistent or brittle, the whole agent fails. This is why reliable, standardized RESTful APIs are truly the engine of agent communication. Let's unlock the value of representational state transfer, or REST.
REST isn't just a technology choice. It's really an architectural philosophy. Its core value is standardizing interactions so that all these different systems can evolve independently without breaking each other.
And that's critical when you have dozens of agents talking to hundreds of microservices.
It's absolutely critical. The first and maybe the most vital principle is statelessness. This means every single request the AI agent sends to the API server has to contain all the information necessary for the server to process it, completely independent of any previous requests.
And why is that constraint statelessness so vital for scaling these modern AI workloads?
Because it makes horizontal scaling incredibly simple. Since the server isn't holding any session state about the client, any request can be routed to any available server instance. You can just spin up thousands of server instances behind a load balancer, and the system can instantly distribute the agent's requests across all of them.
So you avoid bottlenecks.
You avoid bottlenecks, and you avoid the need for complex, expensive sticky sessions or distributed memory layers, which just add latency and failure points. Statelessness keeps the whole system robust and massively scalable.
Okay, what's the second core pillar?
The second is the uniform interface. REST defines a set of standards for how you identify resources and interact with them using HTTP verbs. This uniformity decouples the client, which is the agent, from the server's implementation. The agent doesn't need to know if the server is written in Python or Java or Go.
It just needs to know the contract.
It just needs to know the standard REST contract, and that lets your engineers iterate on the client and server logic separately.
Let's focus on the architecture itself. You said the resource is the centerpiece.
Yes, a resource is the conceptual center. Any piece of information you can manipulate, a configuration setting, a customer record, an inventory count, it's all treated as a resource and exposed via a stable, uniform URI. A uniform resource identifier.
And the client interacts with a representation of that resource.
Exactly, usually JSON or XML. It manipulates the state without needing to know anything about the underlying database or storage.
So URI design is obviously really important here.
It's paramount. They have to be intuitive and predictable. We use plural nouns for collections like users or incidents. And critically, we advise against embedding verbs or version numbers in the path itself.
Why is avoiding version numbers in the URI so important for agents?
Because it leads to incredibly brittle client code. If you release a new API version, say V2, and the URI changes from V1 orders to V2 orders, every single agent calling that endpoint instantly breaks. It needs a full code update.
So what's the better way?
Use headers or media types for versioning. Stable URIs are absolutely essential for the long-term reliability of your agents.
And this uniformity extends to the interaction method, which is the HTTP verbs.
Right. This is the standard vocabulary for state transitions. You have get to retrieve data, which is safe and idempotent.
Meaning you can call it 1,000,000 times and get the same result.
Exactly. Then you have post to create a new resource, put to replace an entire resource, pack for a partial modification, and delete to remove it. This predictable vocabulary allows the agent's reasoning engine to reliably predict what the server will do for any given action.
And finally, communication is governed by status codes.
Essential for the agent's decision loop. The global standard 2xx for success, 4MACX for client errors, 5MACX for server faults, allows the agent to instantly interpret the outcome of its action.
So if it gets an error, it can try something else.
Right. If an agent tries to provision a user and gets a 401 unauthorized, its reasoning engine knows to execute a secondary tool call to refresh its authentication token instead of just failing.
Okay, so REST is the communication protocol, but these complex tool calling agents have to run somewhere at a massive and highly reliable scale. This takes us to the Cloud Infrastructure Foundation.
Correct. The modern AI workload demands infrastructure built on three non-negotiables: cloud elasticity, containerization, and robust orchestration.
So let's start with the cloud.
The cloud scalability imperative starts with the pay-as-you-go model, which just eliminates that huge initial capital expenditure. It lets companies launch experimental agents instantly, but more importantly, it provides elasticity.
Auto-scaling.
Exactly. Using auto-scaling groups, your infrastructure capacity adjusts in real time. If an automated patch management agent swarm suddenly kicks off 10,000 requests, the cloud instantly provisions the compute power needed and then scales it back down when the task is done. That gives you consistent performance without wasteful over-provisioning.
And the need for millisecond startup times, especially for agents that might be called many times per second, that's what drove the industry away from traditional virtual machines.
It was a pivotal shift. A VM bundles a full operating system and can take minutes to boot up. A Docker container, on the other hand, shares the host OS kernel and uses lightweight isolation.
So you get tiny images and super fast startups.
Millisecond startup times. And that speed is crucial for deploying specialized AI agents rapidly. If an agent needs to execute a task and then shut down quickly to save costs, the quick startup and shutdown of containers is indispensable. This whole environment enables the microservices architecture.
And when you have hundreds of these agent microservices running, you need an orchestrator to manage them all.
Which brings us to the self-healing brain of the cloud, Kubernetes, or K8s.
Right.
K8s is really the non-negotiable layer for any production-grade AI agents. It provides declarative configuration. You just state what you want, like, I need 5 replicas of Agent X running, and K8s constantly works to maintain that state. That's the foundation of its self-healing capabilities.
And for managing the stability of the agents, there are 2 key workload types in K8s.
That's right. First, you have deployments. These manage your stateless agents, the ones that can be easily replaced. Deployments handle the logic for zero downtime rolling updates. So when you update your agent's code, K8s gracefully replaces the old versions with the new ones one by one, ensuring you have continuous service.
But the autonomous agents we talked about, especially the ones with long-term memory or that manage databases, they're not always stateless. That's a critical distinction, isn't it?
It is a critical distinction. For agents that have to maintain internal state or access persistent storage or need a stable network identity, like that coordinator agent in a collaborative swarm, we use stateful sets.
And what do stateful sets give you?
Stateful sets ensure stable, unique network identifiers and persistent storage volumes for each individual pod. This is vital. If an agent managing customer accounts restarts, the stateful set guarantees it comes back up with the same network identity and access to its persistent storage, maintaining that critical state that a deployment would just wipe out.
Let's wrap up the infrastructure part with day 2 operations, the safety mechanisms that guarantee reliability. The health probes are central to K8's self-healing.
They are the eyes and ears of the orchestrator. And you really need all 3 probes to maintain continuous service. You have the startup probe, which handles the initial, often slow boot process of a complex AI agent, just to make sure K8s doesn't kill it prematurely.
Okay, so once it's started up,
Once it's started, the readiness probe determines if the agent is actually ready to accept user traffic. If the agent is running, but maybe its database connection pool is full, the readiness probe fails. K8s then removes it from the service endpoints. It stops getting new requests, but it keeps running until it recovers.
and the third probe, the liveness probe.
The liveness probe, by contrast, checks if the application process itself is running without fatal errors or deadlocks. If the liveness probe fails, K8s interprets this as a critical failure, and the orchestrator immediately kills and restarts the container.
So readiness pauses traffic, liveness restarts the whole thing.
Exactly. And understanding that difference is fundamental to designing a reliable, self-healing agent system.
We've covered the business vision, the deep technical stack. Now let's connect this back to human capital. The person who synthesizes all of this, the cloud platform, the REST APIs, the agentic org models, is the AI solutions architect. They're the critical piece bridging that organizational vision and the technical reality.
The architect is the organizational translator. Their core responsibility is taking these high-level goals, like we need 50% faster incident resolution, and translating that into a production-grade, fault-tolerant, and scalable intelligent system blueprint.
And their mission covers a few key areas.
Right. It spans 3 areas. They have to solve real problems, which means designing seamless integration points between the agents and legacy systems using those REST APIs. They have to accelerate revenue by structuring the agent deployment to hit measurable KPIs. And crucially, they must reduce risk.
Risk reduction is often the most overlooked part of building autonomous systems. What kind of GRC governance, risk, and compliance frameworks does the architect need to put in place?
Yeah, this is huge. Risk reduction means instituting robust guardrails from day one. This includes strict bias testing protocols to make sure the agent's decision logic doesn't unfairly disadvantage certain user groups. That's critical for customer-facing agents.
And data privacy.
And strict data privacy guardrails and audit logs, especially for agents handling sensitive data like customer PII or financial records. They have to ensure compliance with global regulations.
So the skills required are a mix of deep tech and executive communication.
It's a fusion, yeah.
Yeah.
Technically, they have to be fluent across the entire distributed system stack. Python, TensorFlow or PyTorch, advanced MLOps practices, and deep expertise in Kubernetes.
But the truly differentiating skill, as our sources suggest, is translating all that complexity into value for the C-suite.
Absolutely. They have to distill complex model behaviors, the deep learning accuracy metrics, the F1 scores, into compelling executive narratives. They have to translate technical performance into tangible KPIs. This 95% model accuracy translates into a 40% reduction in labor hours for the accounting department. That's the language they need to speak.
The pace of this technology is so fast that even the people building the systems are getting help from agents. Let's talk about this profound shift towards AI-driven development.
This is the ultimate self-automation loop. AI-driven development integrates autonomous agents into every single stage of the software development lifecycle, the SDLC. We've moved way past simple GitHub Copilot features.
So what can these new agents do in development?
The new class of autonomous agents in development can now perform end-to-end tasks. They can plan sprints based on project requirements, autonomously write entire code modules that follow architectural rules, run all the tests, manage pull requests by reviewing and merging code, and even deploy releases via Kubernetes.
And the impact?
The results are measurable. They are effectively cutting development cycle times by half.
What's the specialized tech beyond just the core LLM that lets an agent write quality code and enforce rules like that?
It's a combination of integrated systems. Yes, the LLM is the generative core, but it's supported by symbolic reasoning.
And that does what?
That's crucial for enforcing the architectural vision. The agent uses symbolic logic to ensure the code it generates follows the company's design patterns, security standards, and coding conventions. It prevents the automation from just generating a bunch of technical debt.
And it uses RA as well.
Right. It uses agentic RA to reference internal documentation and existing code for context, and it uses reinforcement learning to continuously learn from deployment outcomes and improve its future code generation.
For the listener who's energized by all this, what are the high-value roles that need this blend of cloud and autonomous systems expertise? Where should they be investing their time and education?
The market demand is highest for roles that bridge that gap between AI modeling and scalable cloud deployment. Many people are now seeking credentials that focus on this integration, like the Mancha Certified Autonomous Systems and Cloud Engineer, or MCASCE pathway, which specifically validates expertise in MLOps, LM integration, and containerized deployment with K8s and Docker.
Let's look at the key roles and their financial prospects.
Okay, the AI solutions architect that we talked about, they're commanding $130,000 to $200,000 annually with freelance rates of $100 to $150 an hour. They are the designers of the autonomous enterprise.
Right.
Then you have the deep learning research engineer who's pioneering the advanced models themselves. They're looking at $120,000 to $180,000.
And the builders.
The essential builder is the full stack software engineer who's focused on integration. They're earning $80,000 to $120,000 and $50 to $80 an hour freelance. Their key skills are modern web frameworks like Next.js, React, Node.js, and integrating PostgreSQL with the API endpoints for the agents.
And finally, the data science analyst.
The data science analyst who prepares the data and does the modeling for the LLM pre-training and the RAG systems. They're seeing 90 to 130,000 relying on Python, Pandas, and SQL.
It's just so clear that getting expertise in autonomous systems and cloud infrastructure is now the most valuable currency in the global tech market.
Without a doubt. And these cloud and AI skills are globally transferable US, EU, APAC, because of the standardization from things like K8s and REST. And for maximum flexibility, we see freelance rates for remote AI projects consistently hitting that high range of $40 to $150 an hour. It just reflects the strategic importance of this expertise.
What an incredible deep dive into the blueprint for the autonomous enterprise. We mapped the immense business value of these proactive AI agents, noting that structural shift they enable, getting you that 40 to 70% operational cost reduction. Then we drilled into the technical core, understanding how agentic RAG completely transforms information retrieval through dynamic tool choice and multi-step reasoning.
And we solidified the deployment foundation. We detailed why the statelessness and uniformity of RESTful APIs are so essential for communication, and how Kubernetes uses deployments and those critical health probes to make sure these complex containerized systems run reliably at planetary scale.
It's all about marrying that technical mastery, Python, MLOps, LLMs, with sharp business acumen, which is the role of the AI solutions architect.
And that's the whole game. The transition is already happening.
So we'll leave you with this final provocative thought. We spent some time detailing the rise of these multi-agent ecosystems, these collaborative swarms. Ponder the competitive consequence when these swarms, procurement bots, logistics optimizers, pricing agents start running end-to-end value chains completely autonomously, negotiating and executing decisions in real time.
Early pilots are already showing that this deep collaborative autonomy can yield margin gains of 3 to 5% across an entire organization. And this isn't just about efficiency, it's about competitive survival.
So the time to act is now.
If, as our sources suggest, this current moment represents the cheapest entry point for building and deploying this autonomous infrastructure, what exponential survival tax will firms pay if they wait 3 more years to invest? The autonomous enterprise isn't a trend, it's the ultimate competitive battleground. Continue to explore this frontier.